Hey everybody, how's it going? Alright, I know your physics quiz is tomorrow, it's coming close, so I figured a last minute review video might help. So, here we go. The two important things at the very beginning that we talked about are the word scalar and the word vector. Scalar is anything that tells you how much of something. How far did you go? How fast did you go? How much does it weigh? That's a scalar. It gives you a how much. A vector gives you how much and a direction. You went this fast east. You took this many steps forward. You lifted 32 kilograms up. A vector has a how much, which is magnitude, and a direction. So examples of scalar is speed and distance, and an example of velocity. Example of vector would be something like velocity or acceleration or displacement. So let's talk about that a little bit more. Distance and displacement. Two examples. Distance is an example of scalar. Distance is scalar. It tells you how far something traveled. Distance just is how far. Displacement, however, is a vector. A vector tells you how far something traveled and the direction it traveled in. So if we took a look at these pictures here, we see the distance is the path the mouth walks. But the displacement is more of a start versus end. It's more of a direct line. Again, here the distance that someone walked. Displacement is more of a direct line. So another example of scalar is speed. Speed is how far something moved. That's it. No direction, because it's scalar. So we measure speed by distance over time. This is also sometimes called average speed. So this average speed is equal to distance over time. We measure average speed, or speed, in meters per second, and the distance moved, we measure in meters, and how long that took, now that's measured in seconds. So besides speed, we have something else that's called distance time graphs. Distance time graphs have distance here. Let me make this a little bigger. I know it's hard to see. There we go. Now it's a normal size graph. Alright, so distance is how far something went. Remember, that's scalar in time. It's just movement of time. So in this graph, we see distance and time. We see how far something moved over a period of time. So we see here, this purple line, or this red line, has moved a little further, faster than this line. Here, this straight line, that tells us that the thing has not moved. Look here, at 4 seconds, whatever this is, got to 8 meters. Then at 5, at 6, and at 7 seconds, this has not moved away from 8 meters. That means it stopped moving. Alright, so besides distance time graphs, we move on to something that's a vector. Velocity. Velocity is a vector. It measures how fast, which is a magnitude, and in a direction. We measure velocity with displacement and time. So velocity is equal to displacement divided by time. So velocities can be positive, they can be negative, it depends on what direction something is traveling. The units for velocity are meters per second squared. Alright, acceleration. Acceleration is the change of that velocity over a certain period of time. So we could have something like final velocity minus the initial velocity, and both that would be divided by time. If we have all those numbers, then we know acceleration. Now the units for acceleration are meters per second squared. But acceleration isn't just speeding up. Sometimes acceleration is slowing down. When it's slowing down, we call that negative acceleration or deceleration. It tells us it's slowing down. So we can also look at velocity and acceleration on a graph. So distance-time graphs have distance and time on the graph. The velocity-time graphs have velocity and time on the graph. So here we see a positive acceleration. This positive acceleration is telling us it's speeding up. This straight line here tells us there's no acceleration. It's a constant velocity. The acceleration is the same everywhere on the straight line. Not going faster, we're not going slower. After this point, the line starts to go down. This line's going down. If the line's going down like that, that means something is slowing down. It's deaccelerating. It's getting slower. So the steeper or the more straight up the line is, the more something is accelerating. So this purple line is accelerating more than this green line is. Alright, so those are all your notes on the quiz. It's not a lot. But what I'm going to do here is I'm going to do some of these problems again for you all, just so you can see the problems being done. So this is an acceleration problem that we started talking about in class. So Mr. Engling is late for work, so he increases the velocity of his car from 45 meters a second to 75 meters a second over 6 seconds. What's my acceleration? So what we need is we need the acceleration formula, which I'm trying to write on the board. I'm sorry, I'm writing with my fingers on a tablet here. Oh man, it's messy. V final over V initial divided by time. Alright, let's give this a shot. So, A is going to be equal to, do we have the final? Yeah, we do. See here, since it says 275 meters a second, that's our final velocity. So that's 75. If the sentence says increases the velocity of his car from 45 to, so 45 there, that's our initial. So initial goes on this side. Okay, and we divide it by time. Do we have the time? Yeah, it says over 6 seconds. Oops, I made an extra line there. So here's 6 seconds. Then we do a little bit of math here. 75 minus 45 is 30 over 6. So if we divide that out, A, or acceleration, is equal to 5. And now this is important. You have to remember your units here. 5 meters per second squared. So that's the answer to that problem. Alright, I'm going to clear all this real fast. Alright, this is cleared. Beautiful. What we're going to do is we're going to do the next problem. Whew, this one's a little harder. So, we got me revving an engine. Boom, boom. I'm going faster. I'm about to start a race. And then the race starts. So it says, I accelerate 10 meters per second squared for 13 seconds. Let's write that down. Alright, that's definitely my acceleration here because I have meters per second squared. So I'm going to write that down. So that means I have 10 equal to 13 seconds. Okay, so I have the time. So I'm going to write the time down here. What will my final velocity be after 13 seconds? Okay, well, I don't know my final velocity, so I'm going to write VF because I don't know it. That means they must have given me an initial velocity at some point. And they did. If you look at the problem, it says Mr. England is in his car not moving in the beginning. If I'm not moving, well, if I'm not moving, I don't have velocity. So that's VF minus 0. So that is 10 is equal to VF over 13. So we multiply both sides by 13. And when we do that, we have 130 meters per second. It's equal to our final velocity. Alright, so that's another problem. I think I'm going to find us another problem to do really fast. Let me see what I can find. I'm going to erase this. Oops. I want to put time back there. Good. All right, I'm going to find us another problem. Give me one moment. I'm going to make another problem appear. Boom. All right, there it is. Another problem. All right, we're looking at this problem right here. It's asking for acceleration, so I know we don't have A. Oops. I know we don't have A. In 8 seconds, oh, I know my time now. 8. In 8 seconds, my car went from 80 meters per second. Went from. So that's my clue. That's my beginning velocity. Went from to 30 meters per second. Well, that's my final. So let's solve it. A is equal to negative 50 over 8. Well, that means my acceleration is going to be negative, correct? Well, I'm going to do the math real quick, or I could do this. I know it's going to be negative. My answer is going to be 6.25. Excuse me. 6.25 meters per... Oh, I moved myself. Meter per second squared. Alright, so acceleration sometimes can be negative. It happens. When that does happen, that means the acceleration is decreasing. That means we're slowing down. So acceleration can totally be negative. That's a thing that can happen. Alright, I'm going to erase all this mess. And I'm going to erase the formula too. You know what? I'm just going to take my cool eraser. Ah, that's really small. Nope, it's going to take forever. I'm just going to oh, I can't erase it that way. I'm just going to scroll down. Beautiful. Alright, so I'm going to do another question. I'm going to do this penguin question here. So this is a speed question. We haven't done speed yet. Remember, speed is equal to distance over time. So, for this, the penguin slid to the bottom of the hill in 13 seconds. Alright, we have time. 13. At 8 meters per second. Oh, there's our speed. So I'm missing the distance. To get distance, I'm going to have to multiply both sides by 13. And that gives me d is equal to... Oh, I'm going to have to do math here. 96, I believe it's 104 meters per second. Oh, I moved myself again. I hope I did that math right, so it's not embarrassing. Oh, I did. Yay! It is meters per second. Oh, you know what? I'm wrong. It's not meters per second. It should only be meters because this is distance. Meters per second would be a speed. This is the distance. Alright, I'm going to erase this real quick. And let's see what other question could we go over. Oh, alright, here, let's look at a graph. Here, I'm going to make this a little... I'm going to move this over so you guys can see a graph here. Alright, if we look at this graph, I know it's hard to see. At 2.5 seconds, what's my acceleration? Ah, so this is an acceleration problem. So what I need my acceleration formula. Alright, so my acceleration formula is, let me just rewrite it here real quick. I'm going to move myself out of the way here. A is equal to V final minus V initial over time. So, if we look at this graph, I know it's super hard to see. I'm sorry, I don't know how to zoom in on it. Oh wait, maybe I do. Let's try it. Control O. Oh, well, I certainly zoomed in. But now it's impossible to see. Alright, I made a mistake. Alright, well, just let's do it quickly. At 2.5 seconds, what is my acceleration? So, we know the time. We're going 2.5 seconds. We went from 0 to 1. So 1 is my final at 2.5 seconds. 0 is my beginning. So it's A. A equals 1 over 2.5. So what I'm going to have to do is I'm going to